Hello, my name is Vinay Nair, and you are watching the YouTube channel Vichar Vatika 1. Welcome to this first video that we are sharing on solving a very interesting puzzle, which also happens to be the New Year greetings of 2026. In this video, I'll be taking you through constructing a pretty amazing extra special magic square where it's not just the rows, columns, and diagonals add up to the same magic constant. So when I say an extra special magic square, you might be wondering, well, is it extra special because it has the year 2026 as the magic constant? Well, that's just one of the aspects, but there are a lot more properties in this magic square, and the method of constructing this magic square is pretty old, somewhere around 700 years old. So that's what I'm going to share with you, and I'll also share some fun facts and other details about constructing 4 by 4 magic squares. So here we go. Like I said, the magic square that we are looking at is extra special. As you can see, these highlighted cells, the top four 2 by 2 cells, or any of the other 9 combinations where you take a 2 by 2 portion of this 4 by 4 grid, you will see that those 4 cells also add up to 2026. Wow, isn't that amazing? Because that is not something that is usually common to a magic square. A magic square usually gives you all rows, columns, and diagonals adding to the same total with non-repetitive numbers and as much as possible with only non-negative integers. But here is something which has some extra special properties. And if you look outside of this 2 by 2, what you will also see that if you take any 3 by 3 grid within this 4 by 4 magic square and you add the corner numbers in that magic square. So let me just try to highlight. So for instance, 499, 511, 514, and 502. They also add up to 2026. 506, 510, 507, 503. They also add up to 2026. 512, 500, 501, 513 also adds up to 2026. And 509, 505, 504, 508 also adds up to 2026. And that's not all. You can also add the corner cells of this 4 by 4 grid. That will also give you 2026. In fact, if you add something called as the broken diagonals, that is, if you roll up this magic square in the form of a cylinder, you can see that these highlighted cells form a diagonal, and those are called broken diagonals. They also add up to 2026. You can also take the other broken diagonals like these, or maybe these 4 cells, or you can also take these 4 cells. They all add up to 2026, and there are many more combinations of 4 cells adding up to 2026. Now that is what we call a super amazing magic square, and this is not my technique, and this is what I would like to share with you, how this technique was created, by whom, and how to go about creating such amazing magic squares. So going a bit into the history, this method of constructing a magic square that I'm going to discuss with you was given by a mathematician by the name Narayana Pandita from India, and he had written a text called Ganita Kaumudi, and Ganita Kaumudi means the moonlight of mathematics, so something that shines out in a dark sky. So that is the kind of content that is covered in this text, Ganita Kaumudi. And what I'm going to share with you is one of the aspects from Ganita Kaumudi on creating a magic square. And here's a QR code of our WhatsApp channel where we share puzzles, a lot of interesting fun facts about mathematics suited to people of all ages. So you can subscribe to this WhatsApp channel for more such puzzles and videos. All right, let's get started. Well, as you can see in this 4 by 4 magic square, it's filled up with three-digit numbers. And I would like to take the example of smaller numbers to explain how to construct this magic square. So first what we do is, let's say we take numbers from 1 through 16 and we break them into four sets. Let's call them as set 1, set 2, set 3, and set 4. Each set is colored with four different colors, and you will see why. And what we are going to do is we are going to see how to place these 16 numbers in a 4 by 4 grid and follow that order to make it into a 2026 magic square constant. Okay, so here are the first steps. I hope you have a pen and paper ready with you. As you can see here, 499 is the smallest number amongst all the numbers, and that's placed in the top left corner. Well, that was just a random choice. You can actually place it anywhere in the grid, but let's say that you start with the top left corner, and from there, you have to take a knight's move in chess to place two, which also, is true that if you place a two here, this is also a valid position for two. But let's say that we go this way, we say one and then two, and we skip a row and then write three and take the opposite route to write four. Okay, so this is how we place one, two, three, four, and you can try to see how it is arranged in a particular manner, and you will see that this method or this manner or this pattern is going to repeat for the next three sets of numbers as well. And once we have placed 1, 2, 3, 4, the next task is to place the next set of numbers, which is 5, 6, 7, 8. And placing 5 is pretty easy. You just keep it next to 4. And there are multiple cells next to 4, but you choose the cell which is in a column that was empty. Right? So this column, the second column was empty. So you keep 5 next to 4 and 6, 7, and 8 in such a manner that the numbers that you see over here 4, 5, 2, 7, 1, 8, and 3, 6, they add up to 9, right? And if 5 is to the right of 4, then all the other numbers also should be to the right of 1, 2, and 3. Okay, so that's an easy way to remember, and you can proceed from here to the next set of numbers. All right, so let me just go back. We have placed 1 to 8. The next number is 9. Now 9, I need to place in a cell that is diagonally alternate to 8. What do I mean by diagonally alternate to 8? You skip a cell diagonally and then you go to this. So this is what I mean by diagonally alternate cell, and that's where you need to place 9, and you can see that that's where 9 is placed. And you will also see that 8 plus 9 gives you 17, 10 plus 7 gives you 17, 6 plus 11 is 17, 5 plus 12 is also 17. Which means you need to place 10, 11, and 12 in diagonally alternate cells of 7, 6, and 5. So which is why you see 10 is in the diagonally alternate cell of 7. The diagonally alternate cell of 5 is 12. The diagonally alternate cell of 6 is 11. And they all add up to 17, just like 8 and 9. So if you think about it, you only need to know how to place or where to place 1, 2, 3, 4. And if you know where to place 5, 6, 7, 8 automatically takes its position. And then it's about filling the remaining cells with numbers that, in such a way that the diagonally alternate numbers add up to the same constant, or they add up to 17 in this case. Then we arrange the remaining four numbers. So as you can see, 13 is in the diagonally alternate cell of 4, and 13 plus 4 is 17, 14 plus 3 is 17, 15 plus 2 is 17, 16 plus 1 is 17. So basically the four empty cells, you just fill it up with numbers that diagonally alternate cells, that makes the diagonally alternate cells add up to 17. Okay. So there we are. There we are with a magic square with 1 to 16, which also contains all these properties which I mentioned about the original magic square of 2026, where if you add any four adjacent cells, like 2 by 2 squares, their numbers also add up to the same constant, which in this case is 34. Okay. So this is the beauty of Narayana Pandita's algorithm. And these kind of magic squares, which have more and more properties, they are also called by other names. Some in some civilizations they called it by some names, but I have read names like diabolic magic square, pan-diagonal magic square, doubly magic square, and so on and so forth. Okay. All right. So this is how you make a 4 by 4 magic square. However, you might think, okay, so this is with the numbers 1 to 16, but how did you make this magic square with the constant 2026? Hmm, that's little interesting. So what I'm going to do is, so that I don't spoil the fun, I will not tell you how I chose the numbers within the cells, but I'll just tell you how to use this 1 to 16 magic square and create the 2026 magic square, while I would want you to figure out how did I choose the numbers from 499 to 514, and how did I know that that will be those 16 numbers which can actually fit into this 4 by 4 grid and make it a complete magic square? So that you can try on your own. Do share your thoughts in the comments. Right. So first we create a 4 by 4 grid, and we keep the four sets in the same order as we had done for 1 to 16. So the first set is 499 to 502. We place them in the same arrangement as we placed 1, 2, 3, and 4. Okay. And then we move on. We see, okay, the next set is 503 to 506. And 503 to 506 is equivalent to 5, 6, 7, and 8. So just as we placed 5, 6, 7, and 8 close to the first set of numbers, we place 503, 504, 505, and 506 in the same manner. So we are done with 50% of the numbers, and then we just have to find diagonally alternate cells. So 506, the diagonally alternate cell is this one. So here we keep 507. Maybe I should just take a red color over here so that we are clear. So this is 507. And then I ask, okay, 505, the diagonally alternate cell is empty. Here we should have 508. And then 504 and 509. So I look at diagonally alternate cell of 504. So this should be 509. And then we have 503. Diagonally alternate cell is 510, 510. And this is one way how you can remember, or you can also remember this as it was 507 from which we started. So we take a knight's move, we come to 508, and then we skip a row, we go to 509, and then we take the knight's move and do 510. Okay. Yeah. So this is another way to remember the method. Well, we are done with this. And finally, the last four cells. The last four, again, you try to check, okay, 511 and 502, they should be in diagonally alternate cells. As you can see, 502 is placed here. So this was an empty cell. As you can see, this was an empty cell, and that has to be replaced with the diagonally alternate number that should come there, which is 511. right? And similarly, you can see that 501, the diagonally alternate cell should be 512. So 501 and 512, right? So that's how we fill out the remaining numbers. And if you add any row, column, diagonal, or as I mentioned, any 2 by 2 grid, the numbers in 2 by 2 grids, it will all give you the number or the magic constant 2026, right? So I hope that was a magical start for your new year. Do subscribe our WhatsApp channel and follow the YouTube channel at Vichar Vatika 1 for more such videos, and try to make your own magic square with a particular total that you want to have as the total of the magic square. And let me know if you face any difficulty in the comments, and I'll try to create another video to help you out. Yeah. Thank you. See you again.